Moving to the next question, that is question number 4, exercise 7.3. What we have, it says that BE and CF are the altitudes, are two equal altitudes of this triangle. That means this altitude BE and the other altitude CF are equal, right? As you can see, it is mentioned equal. All right. Then there's a restriction given, right? We have to use RHS to prove these two triangle congruent. Sorry, we have to prove, yes. Using RHS, we have to prove these two triangle congruent. Now, obviously, we'll prove these two triangle congruent, and therefore we will prove this an isosceles triangle. So, in short, we can say that we have to use the condition, that is RHS congruency rule. And obviously, when proving these two triangle congruent, we can write this side AB as equal to the side AC. So in the first part, what we'll do, you'll use RHS to prove two triangles congruent, and here the triangles we'll be choosing congruent should be this one. That means this one. There is a reason why I'm considering this two triangle. As you know, there is a common hypotenuse BC, which is opposite to 90 degree, right? So this is the reason why I am selecting this triangle. Right. It can be done in an alternate way, but it's being mentioned using RHS, so we must go by this method. And the other triangle is this. So let's prove these two triangle congruent first, and then we'll see what to do in the next part. So we'll first consider this triangle, that is here the triangle is BFC, and the other triangle is CFB, right? Once with these two triangles taken, we can write one angle 90 degree in each, that is angle BFC is equal to the angle CE. This is here, CEB. And the reason here is each 90 degree, as these are altitudes. And as I said, BC is equal to BC. This is common hypotenuse, right? This is common hypotenuse. And then we have to also look for a side. As you can see, BE and CF are two equal altitudes. So we can also write BE being equal to CF. And the reason for this is given. So therefore, the triangle A, that's a BFC. The triangle here is BFC is congruent to the triangle CEB. Now, clearly we have used RHS, right angle hypotenuse side, to prove the triangle congruent. Now, once we prove this to triangle congruent, we have to now think how to prove this as an isosceles triangle. For that, let's understand, when you prove these two triangle congruent, from CPCT, I can write this angle B is equal to angle C. We can write here, that is angle B is equal to angle C. That's from CPCT. But that's not sufficient to say the triangle isosceles, as we need to prove AB is equal to AC. So we'll again consider the same triangle, not the same, that is the larger one, that is triangle ABC. We have angle B is equal to angle C. As you know, when two angles are equal, then sides opposite to these two angles are equal. So the sides opposite to these two angles are, that is, one is AB, another is AC. So therefore, we can say this triangle ABC is an isosceles triangle, is an isosceles triangle. And that's how this question can be proved.